Today we're doing the Pythagorean Identities, section 10.3. And Pythagorean should remind you of something. The Pythagorean theorem is that in a right triangle, a squared plus b squared equals c squared. And basically the theorems that we're looking at today, or the identities that we're looking at today, are based off of this. So we're going to start with the unit circle, which recall has the equation x squared plus y squared equals 1, has a radius of 1, and a center at 0, 0. And together with that, we learned that every point x, y on the unit circle had the coordinates cos theta, sine theta. So we can pick out our x and our cosine theta because they represent the same thing on the unit circle, and our y is sine theta on the unit circle. So this is all review. If we now take our equation for the unit circle, x squared plus y squared equals 1, and we substitute in for x, cosine of theta, squared then, and we substitute in for y, the sine of theta, we get this transformed equation, cosine squared theta plus sine squared theta equals 1. And it's really, again, it's just the Pythagorean theorem. I think I have a circle up there, but I'll use this one. If I have an angle, let's just put one in quadrant 1. We know that if I have this angle theta here, and I'm in the unit circle, that this section from here to here is represented by cosine theta because it's the x coordinate or the x distance, and this height, the height is represented by sine theta. So if we moved over and up to get to this point, we've gone over cos theta and up sine theta. But what I want you to focus on here just to see is that this is a right triangle, and if we apply a squared plus b squared equals c squared, a squared plus b squared equals c squared, then we have cosine squared theta plus sine squared theta equals 1. So we can think about that in a couple of different ways. All right, let me get that back over here. So we use this identity to do some problems now. We'll get to those down a little farther, but let's check the identity out. Let's check the identity out on your calculator. Definitely watch for a mode change here. So let's try typing in cosine squared of 45 plus sine squared of 45. And I'm going to bring my calculator up because I want you to understand how the button presses work. There it is. So when we square trig functions, that little squared is tucked in after the function, like cosine squared. But what we end up pressing, or what you see on your calculator, is a little different. So let me clear everything in here. To do the cosine squared of 45, let me check my mode. So I'm in radian mode. Let me change that. 2 degrees. Second, quit. I'm still going to hit cosine. It's ready for the angle, so we put in 45. Close your parentheses, and then square it. So we're doing cosine of 45, all squared, plus. Now let's put in sine of 45 squared. Close that angle parentheses, then square it. And you should see 1. So cosine squared theta plus sine squared theta equals 1. Let's try the next one. It says cosine squared 2 pi over 3. I'm just going to switch my mode. I'm going to go, how does it keep going back to radians? Interesting. I never switched it last time. That would still give you 1, even if those were radians. All right, cosine of 2 pi divided by 3. Close your parentheses and square it. Plus sine of 2 pi divided by 3. Close it and squared. So this is how we do functions squared. And when we hit enter, again you see 1. And then the last question there, that was 1, this was 1. The last question there is cosine squared of 210 plus what would give you 1? So of course, it's sine squared of 210 degrees. Sine squared 210. So when you put these in your calculator, they actually look like that, with the squared on the outside. Okay, just a little practice. This is an identity. Identities are things that are true for any value. So this is a formula you should put on your formula page. We're going to have 2 more in just a second, but you need to memorize this. It is not given to you. Well, there's 2 more. So the next one, we start with the one we just did. Matter of fact, both of them, we start with what we just did. And what we end up doing is first we divide through everything by cosine squared of theta. So we divide through by cos squared theta. And then that gives us cosine squared over cosine squared is 1. Sine squared over cosine squared, do you know what that is? Sine over cos is tan, so if I'm squaring them, I get tan squared. And 1 over cosine is the reciprocal for secant. So our next identity is 1 plus tangent squared theta equals secant squared theta. You could probably guess on this one, this last one, we're going to divide through by sine squared theta. So we'll do this on the left and on the right. So the first quotient is cosine squared theta divided by sine squared theta. Cosine over sine gives us cotangent. Sine squared divided by sine squared is, of course, 1. And 1 over sine squared is our very last function, cosecant. So now we have our last identity, cotangent squared theta plus 1 equals cosecant squared theta. So together, we have 3 new formulas, all stemming from cosine squared plus sine squared equals 1, which came from this circle up here. Divide through by cosine squared, we get the next one. Divide through by sine squared, and we get the last one. So knowing how to do it could help you if you ever forget any of them, actually, the last 2 especially. So now how do we use these? When you're given a problem that asks you to find a function and they give you some information. So in this case it says find the cotangent of theta given cosecant of theta equals -2. And of course we need to remember we are in quadrant 3. So our quadrant always matters for the sign of the function's value. All students take calculus. We'll come back to that. So since this problem deals with cotangent and cosecant, And that's actually not what's on my notes. It doesn't matter, I can still do this. I don't know if you guys have this one or not. Okay, we'll just do it. So since it deals with these two, I know I have cotangent squared theta plus 1 equals cosecant squared theta from the identities that we just did. So I'm going to substitute in what I know. Cotangent is what I'm looking for, cotangent squared. And cosecant is -2, and I'm going to square it. This is not squared, so I need to square it. Do some arithmetic. Subtract this 1 over. And we have cotangent squared theta equals 3. Square root both sides. When you square root, u plus minus. Don't forget. So we have positive, negative, square root of 3. And the sign comes from the quadrant. So if we are cotangent in quadrant 3, cotangent in quadrant 3 is positive because tangent is positive in quadrant 3. So we have cotan of theta equals square root of 3. And we're done. Let's try another one. The next one says, find sine theta given cos theta. Awesome. The very first Pythagorean identity is that cosine squared of theta plus sine squared of theta equals 1. Let's substitute for cosine, 8 over 17, and cosine is squared. Plus sine squared equals 1. 8 squared, 17 squared. And I like to change my 1 right now. If I see I have a denominator of 289, I'll just make this 289 over 289 so that I can do some mental arithmetic. So now I'm going to subtract over the 64 over 289. And let's continue up here. That leaves me with sine squared theta equals, go ahead, 225 over 289, square root, u plus minus. So sine theta is either positive or negative 15 over 17. And what determines our sign? Our quadrant. So if we are in quadrant 4, and we're dealing with the sine of an angle, then you are negative. So the sine of theta is negative 15/17. So what we've shown so far is that we can go and use those 3 identities to solve some problems. Quick little review and reminder here. Might happen that we can use some other identities, and these are always good to recall and know. Cotangent is the same as 1 over tangent. Secant is, try and be a step ahead of me, 1 over cosine. Cosecant is 1 over sine. And then our quotient identities, tangent equals something over something. Sine theta over cosine theta. Cotangent flips that. And that's all for those. We might need those in the next few questions. Definitely knowing the reciprocals. So let's see what we have here. More problems. If cosine theta is 2/5 and theta is in quadrant 4, Let me put my quadrants down again. So we're in quadrant 4 here. Then find the values of the other 5 trig functions. So really we want to do all 6 here, but they've given us information already. Cosine is 2/5. So now we know that secant is a reciprocal. And let's just bracket these off so we can flip them when we're done. If we know cosine, we can use the identity with cosine in it to find sine. So let's do that. 2/5 is cosine squared plus sine squared equals 1. 2/5 squared is 4/25. I'm going to turn my 1 into 25/25, 25/25, because I know I'm subtracting over 4/25. So now I have sine squared theta equals 21/25. Square root, plus minus. Sine theta equals square root of 21/5. And is it positive or is it negative? Well, up here I circled our quadrant. Only cosine and its reciprocal are positive. So I know then that we have a negative square root of 21/5. And I'm going to flip that for cosecant. And of course rationalize. All right, we have 2 more to do, tangent and cotangent. And here's where those other identities are coming in handy, not just the reciprocals and flipping them, but we know that tangent is sine divided by cosine. So if I take and divide this by this, then you know you're going to get negative square root of 21/2, because the bottoms are the same. Then I'm just going to flip it for cotangent and rationalize. And there we go. We have the values of all 5 extra trig functions. And do another last minute check. Do you have all the signs right? Only cosine and its reciprocal should be positive. Excellent. So let's try this next one. We have tangent as the given value, and we are in quadrant 2. Oh. Drop my pen. In quadrant 2, so we already know sine should be positive and it's reciprocal. I've had students that just like to do that right at the beginning so they know what's positive and what's negative. That's okay. They gave us tangent is -3. We know cotangent flips it, so we've got 2 of our 6 already done. -1/3 is cotangent. The Pythagorean identity that we're going to use is 1 plus tangent squared equals secant squared, because they've given us tangent in the problem. Equals secant squared. This will help us find secant. 1 plus 9 is 10. Square root, square root. You square root a number, you plus minus. Well, is it positive or is it negative? Radical 10. We are in quadrant 2. See how many times I check this. where we already know our secant is going to be negative. So the secant of theta is negative square root of 10. Cosine is its reciprocal. Do a quick rationalize. And then the last part is, how do we get sine or cosecant? Well, since I have cosine, I can find sine because they have a related Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. So let's substitute in cosine theta. You can use the original or the one that we rationalized. I'm squaring it, so using the original will be a little less work. That's 1/10. I've got a denominator of 10, so I'll make this 10 over 10. That's a squared. Subtracting 1/10. Square root, plus minus. You really want to think about, is it positive or is it negative? Square root of 9 is 3, and I have a radical 10 on the bottom. Remember where we are. We've already written the signs. We're in quadrant 2 according to the problem. So we know in quadrant 2 sine is positive. So we knew it already. We filled them in early, but it's always good to check, check, check. 3 over the square root of 10 is 3 square root of 10 over 10. And when you flip it, using the original is easier. Square root of 10 over 3. And of course, that's positive as well. So that's it for those. We're almost done with the lesson. At the end of the lesson, I'm going to come back and I'm going to do these two in an alternate way. Just I want to mention something, and I'll probably squeeze it in somewhere, but I want to come back to these. Let's see what the next page brings. Okay, here's one for you to try on your own. I'll check that when you get to class tomorrow. You're given sine. And notice, please, you're in quadrant 3. So set them up early. Figure out where you are, what you need. All students take chemistry. We are here. So you should already know what's going to be positive and what's going to be negative. All right, so the bottom here is a slightly different type of problem. This says, write each expression in terms of sine and cosine only, and then express your answer in simplest form. So we're just going to do some substitutions here of the identities that we know. Cotangent is the same as cosine divided by sine. And since they want sine or cosine in your problems, we're going to keep this one. So we're going to put it sine theta over 1. And then you're really just doing either some reducing, or maybe you're adding fractions. In this case, I'm multiplying, I'm going to reduce. So this just simplifies to cosine of theta. The next one, cosecant, I know is 1 over sine, plus, and cotangent is cosine over sine. Adding fractions, you need a common denominator. Adding fractions, need a common denominator. We have a common denominator. Yoo-hoo! And it's sine theta. So on the top, 1 plus cos theta. And that's all we can do. We've combined cosecant plus cotangent, and it is the same as the value of 1 plus cosine, all divided by sine. Last one, number 5. So anytime I'm given a division problem, I like to recommend that you first write it out like this. Proceed cautiously here. So we have cotangent divided by cosecant. Now substitute your identities, keep in division, and then you have cosine over sine divided by a fraction. We're going to multiply by its reciprocal. And you can see we reduce our signs, we're multiplying, and we're left with cosine of theta. Okay, so that's it. Let's, I said I wanted to just peek back at that other page and show you something that would tie us back to the beginning of the unit. For these two questions here. Remember, we were already able to find the 6 trig values using SOHCAHTOA. So I want to just examine real quickly what that would look like. When you're given information in a problem, I'm going to use a little room right here. You're often given enough to do all of the trig functions. So if I know I'm in quadrant 4, I'm going to draw a little angle into quadrant 4. Quadrant 4 up to the x-axis. So I'm dealing with that. Cosine is 2 over 5. So I'm going to call that the adjacent and the hypotenuse. I'm going to label my adjacent 2, my hypotenuse 5, and I'm going to go find the opposite side using the Pythagorean theorem. All right, a little quick work here. We see that it's radical 21. And then from here, let's just use SOHCAHTOA. If you look at the opposite, it's radical 21 over the hypotenuse, it's 5. And it's negative because you're in quadrant 4. The cosine is the adjacent over the hypotenuse. Let me write these in. The tangent is the opposite over the adjacent. There's your SOHCAHTOA. Whoops, I didn't mean to do that. I meant to do that. And then the cotan flips it, the cosine flips for secant's value, and the sine answer flips for cosecant's value. So these can really be done still with SOHCAHTOA. So now you have options. You can use the Pythagorean identities or still SOHCAHTOA. So if you're going to draw for tangent theta equals -3, and we're in quadrant 2. There's a quadrant 2 angle, perpendicular to the x-axis. If they tell you tan is -3, and you know tan is OA, SOHCAHTOA, so you need another number, -3, can be put over 1. All right, and then you've got your opposite and your adjacent, and you figure out your hypotenuse by the Pythagorean theorem. Same stuff, it's going to turn out to be radical 10, and then you're just going to do SOHCAHTOA. So the old-fashioned way works fine. I would recommend practicing with the identities. Memorize those, put them on your formula sheet, and have a great day.